Hello. Hello, and welcome back to Quantitative Reasoning Online. Lesson 6, Lesson Plan 6, Lesson 14C, Review. Let's take a look. Conclusions and observational studies, an interactive tutorial with 2 questions. Wow. So let's do our observational studies, conclusions in, and quantitative reasoning online. And we have one objective. Describe the characteristics of a good observational study design. First of all, what's an observational study? Keyword being to observe. Therefore, not influence. No treatment. Observation, you just look at data. In this class, you will practice making conclusions about observational studies. Recall previous lessons and the statistical concepts of experimental and observational studies, simple random and stratified sampling, and how to minimize errors. Think about all the concepts that you have learned as you pick the best conclusions for the studies shown on the upcoming screens. Tutorial for the preview of Lesson 14, Part C, Conclusions Observational Studies, begins here. Question 1. Describe some characteristics of a good observational study. Well, I kind of gave a little bit already. 1. The observer, recorder, does not influence the outcome of the study. If the study is done by surveys, no leading questions. Good simple random sample / sampling technique used. Basically minimize bias. What's some of the hints? Okay. Review the prompt and enter response in the box. Read about intelligent quotient test and how it is measured at such .htm. Notice the nicely symmetric graphs. Use the graph to estimate the mean IQ score. So let's go get this guy. Copy. What is an IQ test? And what are you supposed to be looking for? Notice the nicely symmetric graphs. Okay, let's go notice the nicely symmetric graphs. You can read this on your own, by the way. Okay, I'm not seeing a graph here. But of course, something has probably changed. So, hey, here's a graph. Okay, so here's the distribution of the IQ test. So it'll look like, let's go back to the question. Notice this nicely symmetric graph. Use the graph to estimate the mean IQ score. Well, the mean IQ score is right around the balance point. I mean, it's nice and symmetrical. So the mean should be right in the middle, along with the median. So it looks like a mean IQ score is of the population, of any population, should be around 100, using a standardized IQ test. The IQ tests are standardized to basically fit this distribution curve where, basically above very smart, way smart, smart, pretty smart, average, and so forth. So I'm going to say 100. And it's confirmed in the reading. Is it? Is it now? Seeing how the reading has changed. Does what's low, what's high. 90 to 109 is average. 110, 119 high average, 120, 129 superior, greater than 130 very superior. And so we are basically built around an average of 100 for an IQ. Excellent. Review the prompt, enter response. According to the reading, very few people, approximately 0.2%, score above or below. Let's see, in here somewhere. 0.2% score above or below. Here we go. 145 or less than 55. So very few score above 145, 0.2%, or below 55. $145, $55. I also kind of notice this is 100, 145, 55. The difference, the same number of IQ points. So those are the same distance apart from the mean. And if you look at the curve, when I had up, let's see, I guess here's 145, and here's 55. There's very little left area-wise under the curve. It's not quite at zero yet, but only 0.2% of the population fall either above or 0.2% falls below those two numbers. Now, of course, when you think about really big numbers, $330 million people in the United States times 0.2%, which would be 0.002. What number is that? How big is that? 330,000,000 times 0.002. Still talking about 660,000 people. In the United States, 330 million, 660,000 would be greater than 145, and 660,000 would be less than 55. Wow. We talk about big numbers like that, that's not insignificant. Okay, within the rating, there's a hyperlink labeled representative sample. Click on the link. Which of the following is not a characteristic that is generally important when determining a representative sample? A representative sample. I've seen that someplace. Let's find it. Representative sample. Should be in blue. Lowest scores. Average score. Fair head score. Here we go. This involves administering the test to a representative sample. Let's click on it, see what happens. So let's see what we have here. Wrong one. What is not on the list? So which of these are not? Or which is not? Sex, age, education level, hair color, social status, marital status. I'm gonna go with the gut. I think the answer is hair color. It's not what you would choose somebody on whether for doing a IQ test. So let's see, what do we have here? Okay, I've been kind of like scrolling around on my own. It's like I'm not finding the answers I'm looking for in this article. So a link's been changed over the years since this class was made. Let's think about it. Let's think of this on our own. If we're going to do a study, particularly for an IQ test, think about if you want to try and break the study down in the subgroups. Would it be worthwhile to someone along the line be able to say, gee, let's do some testing. Let's do some testing and let's see if there's a difference between IQs based on sex. Is that about valid test criteria? Yeah. So when you're doing your studies, doing your sample, you're getting your population built up. If half the population is female, you probably should have half the members of the study female also to represent the population. Be worthwhile to try and do a breakdown of age. Gee, you think the IQ of a 12 to 18-year-old would be different from an IQ of a 30 to 35-year-old? Maybe worthwhile to be able to have an age discriminator in there. So again, when you do your study, when you do your building, you may want to block your study in the population, into a population grouping. Education level, you think that may have an effect on IQ? Whether you're never graduated high school, or you're a high school graduate, or a college graduate, or well learned, yeah. Hair color. would there be a valid reason for, gee, what, is there an IQ difference between a redhead and a blonde? Or a brunette? Or a, what are the colors out there? That's not artificial, no. You always have purple and green. Okay. Socioeconomic status? Hey, someone who is born with a silver spoon in the mouth versus someone who's not. Then maybe an IQ difference there that'd be worth discriminating against or distinguishing. Marital status? There's a difference between IQs of married people and single people or divorced people. Maybe. So I think in this question here, which is not a characteristic that's generally important when determining a representative sample? Holy mackerel. A representative sample. Hair color. And if all has failed, find out. But we're able to successfully argue hair color based on, gee, what just makes sense in terms of a representative sample. Now, there may be some studies out there where you want to have hair color as a determining factor. Example being the hair coloring people. Hey, does people who are blonde take a coloring different than one who's a brunette? No. Such as, I want my hair purple. Would that dye give a blonde person different purple than a brunette person, or a redhead a different purple? So there may be some valid. So just don't totally eliminate it. But at least in the terms of doing an IQ study, I don't think hair color comes in play. Sure, all else fails, do a 4. How confident are you that you can describe the characteristics of a good observational study design? Yeah. Done. So, back to where I want to be. Here we have a tutorial for conclusion and observational studies completed. Painfully. I'll see you shortly, so go do it yourself. Think about what I explained, how I explained it. Rambled sometimes. And I'll see you shortly for question 1 and 2. Also do some more research on verifying those parameters that we discussed. Hair coloring is not it.